Hello, my name is Dr. Linda McIver and I run the Australian Data Science Education Institute. We're a charity dedicated to helping kids understand data. Today's topic is some of the ways graphs lie to you. I'd like to cover all of the ways, but we'd be here all day and we still wouldn't have finished. So graphs are a really important way of conveying information. If I give you a list of numbers, it takes quite a lot of work to figure out what they mean. But if I put them in a graph, that is the right graph, they can tell you a really useful story about your data. So this video was inspired by a post on the ABC News website about the rate of community transmission of COVID-19 in Victoria. To their credit, they deleted the graph when I complained about it on Twitter. So they didn't intentionally mislead, but it's really interesting to see the way it panned out. So I'm going to flip over to sharing my screen now so that you can see it. So the first problem is the labeling on the y-axis. We start from 1 over here. The next line is 10, you would assume that between the 1 and the 10, the next one up would be somewhere around 19 or 20 and would be the same distance. You want to know what this top value is, you would assume it's somewhere around 19 or 20, yeah? Unfortunately, the fine print here says that this is a logarithmic scale. Now, this is a perfectly valid way to display data and gives us a lot of useful ways to interpret the information, but it's not a way that most people are familiar with. So if you look at that graph and don't notice the fine print or don't know what a logarithmic scale means, you would assume that this top value was somewhere around 20. In actual fact, it's 39. Now, you'll see also they say get the data, which I think is a really useful and transparent way to display data. If you're going to show the data, then give people the access, the opportunity to work with the data themselves. So this is the data. It's a very simple data set. And again, you can see there's something kind of familiar in the way these numbers behave. They're small, they're small, they're small, and then suddenly they start getting quite large. And you can see here that the top value that on that graph looked like somewhere around 20 was actually 39. So let's graph this data together. We'll insert a chart. Now, this is a linear graph, and you can see that it's a very different shaped profile to the one we looked at from the ABC website. I'm going to flip back to that for a second. It looks like a slow linear growth, but if you look at the linear graph, it's quite clearly exponential. Now, the other thing about this graph is that the labels on the y-axis are very clear. You've got 0, 10, 20, 30, 40. You can see what the top is. You can see the progression, and it's obviously linear. Now, if you're going to use a log graph, it's really important to make it very clear how the values are actually growing. And we can do that by going to the vertical axis and saying, make this a log scale. Now, on Google Sheets, you actually get the lines which show you how differently the values progress on a log scale. You can see from 1 to 2, there's a big gap. 2 to 4, 4 to 6, 6 to 8, the lines are pretty close together. 8 to 10, the lines are super close together. And then from 1 to 10, from 10 to 20 is about the same size as the 1 to 2 was initially. So this is a log graph. Log graphs give you a very easy way to read off the rate of doubling or the factors by which things are multiplying, but they don't give you a clear sense of growth unless you are really familiar with them and used to reading them off. Let's change it back to a linear scale. You can see how different that curve is. And how much scarier, quite frankly, when we're talking about community transmission, when we're talking about a dangerous disease like COVID-19. So there are some other ways in which graphs mislead you, and I want to show you now one of the really obvious ones, which is about having a 0 on the scale. So if we graph this in Google Sheets, we insert a chart. Now, you can see that there's very little difference between these values because, 98, 95, 96, 101, they're all very close, and that's what they look like on the graph. However, if we do that in Excel, So we have the same data set, exactly the same numbers in the same order. And now we're going to insert a chart. Suddenly, these values look wildly different. Why do they look wildly different? Because there's no 0 on the y-axis. You can see the y-axis starts at 92 and goes to 102. So it's basically using the range of data plus a little bit of wiggle room to represent the graph. Now this is perfectly valid, but it's incredibly misleading if people don't check for 0. So that's one of the first things you should do when you look at a graph is check for 0. Is there a 0 on this scale? Is the size of the values, size of the difference that it's showing me actually valid? Is it actually as big as you think it is? Okay, so let's look again at this original log graph. When you make a graph, the intent is to communicate some data to somebody. And the important thing to think about, as with any form of communication, is what am I trying to say and who am I trying to say it to? In this case, the intended audience was the wider community, who for the most part don't understand log graphs and aren't familiar with reading them. But the other thing is, the main point that this graph was trying to get across was the rate of change. And a log graph communicates that really effectively to scientists, but not to people who aren't familiar with log graphs. And you can't read off the top number. You have no idea what the value is here because there's nothing on the y-axis that tells you what the value is up here where it reaches. The only value that you can reliably read off this graph is where the line intersects with the 10 and where it intersects with the 1. That's the only place you can know for sure what the values are in between. So it's really important to think of graphs as a way of communicating and ask yourself, anytime you make a graph, have I made a graph that communicates the values I want to communicate or the point that I want to get across, and is it appropriate for the audience I'm targeting? This has been another Data Science Explainer from the Australian Data Science Education Institute. If you like it, share it, and you can donate to support the making of these videos at givenow.com.au/adsei. Have a great day, stay safe, and see you for the next video.